Okay, so alright friends, let's start the realization of or making of AND gate, OR gate and NOT gate using the transistors. So what we do is we should very well define first of all what do we mean by a positive output, zero output, and what do we understand by one output. So one output means a high voltage output and 0 means a low voltage output. Now how low is actually low voltage and how high is actually a high voltage? For that we define two things for the output voltage, which is called VOH and VOL. For example, when we say that the high voltage is from 5 volt to 7 volt and the low voltage is from, let's say, 0 volt to 2 volt, so 0 to 2 is low and 5 to 7 is high, then we say that the lower limit of the high voltage is VOH. For the high voltage, what is the lower limit? 5, which is the minimum output voltage for the output voltage to be called as the high voltage or high signal. Similarly, the upper level of the low voltage or zero output, for example 2 here, so this 2 will be called as VOL, which is the maximum value of the voltage, so that the voltage can be treated as a low voltage or a zero output. All right, so we are concerned with this and this. Upper it can go, doesn't matter, and here it lower also doesn't matter. So these are the terminologies which are written, VOH and VOL, and similarly on the input side also these values are written. Now the input VIH, VIL and output VOH, VOL can be different. For example, the input is generally applied across the base emitter PN junction, and the input voltage can be, let's say, from, if it is low then we can say it is 0 point, because we know that the base emitter PN junction should be sufficiently forward biased. That means if the voltage across the base emitter PN junction is less than 0.6 volt, then we know that it is not sufficiently forward biased, and so the current will be very small. So we can say that since the currents will be small, the voltage is, we can consider it to be the 0 volt. So 0 to 0.6 volt can be considered as low input voltage, and we can say that the higher input voltage can be, let's say, from 1 volt to 1.2 volt, which can be considered as a high input voltage. I'm just giving an example, you don't need to follow exactly these values. So this again will be called as VIH, and this is VIH, and this is VIL. What is the minimum value of the input voltage for the input voltage to be categorized as the high voltage or high input, or one input plus one input, because plus 1 and minus 1 plus 1 and 0, and this all will be considered as, so all the voltages in this range will be considered as low input voltage. Low input voltage means zero input, so we said that the input is 0, or we said that the input is 1, 0 and 1. And what is VIL? VIL is the, again, the maximum value of the input voltage, so that the input voltage can be considered as a low voltage or zero input. Now you are already aware of this terminologies. How do we know that this is VCC and this is RC, and this output here is this? But we know that all the voltages are applied with respect to the reference level, and this reference level is the earthing level, which in this case is done for the emitter in case of this NPN transistor. So when this is VCC, we can automatically understand that VCC applied, a positive value of VCC, for example VCC is given to be 12 volts, so a positive value of 12 volt is applied with respect to this, which means that there should be a battery, there must be a battery between this reference level and the VCC, and this should be a 12 volt battery, isn't it? That's the meaning of plus VCC. Similarly, so when a voltage is written as plus VCC, it is with respect to this. Similarly, when we say that we are taking an output, actually we are taking output with respect to this, so output is taken across this and across the earthing. So this is 0 volt versus the output, so this is the output voltage, which we are calling just as this, because this is anyway common, isn't it, for everything. Now this is a NOT gate. So what is a NOT gate? A NOT gate means when the input voltage is low, this is the input, which is A, NOT A is represented by A bar. When the input voltage is low, the output voltage is high, and when the input voltage is high, the output voltage is low, and this is what is output, which is VO output. Now let's understand how it is working and why it is or can be called as a NOT gate. So as we know that this is a NPN transistor, so this is NPN here. So when we don't bias it, that means when we supply a 0 volt here, so since there is no biasing, and when there is no biasing on base emitter side, nothing happens, and which means when we don't supply any voltage across the base and emitter p-n junction, that we don't connect it to a battery, no input voltage. No input voltage means no current, no input current means no collector current, so this current becomes 0. So when there is no current here, this IC is 0, and when this current is 0, that means whatever is the voltage here, same is the voltage here, because there is no voltage drop across the resistor. See, voltage drop across the resistor will happen only when there is a current, and now we are understanding that when we don't supply any voltage here, IB is 0, IC is 0, and so no current here, so no potential drop. So this is VCC and this is also VCC. So if this is 5 volt or high voltage, or maybe 12 volt here, this output is also 12 volt, so this becomes high. So when this is 0, this is high, 0 high. Okay, now what when we supply a high voltage here input? Let's say we apply the input of 1 volt instead. So this is 1 volt can be considered as a high input voltage. So this is 1 volt here. When we supply this 1 volt, we can understand that this base emitter PN junction will be sufficiently forward biased, and so there will be current through this battery of 1 volt, or and because of this there will be a good amount of IB, which will drive a good amount of IC, and so there is a lot of IC flowing. And when there is a lot of IC flowing, what is the potential of this point? Well, if we start from here with VCC, so we start with VCC and we go across this resistor, and we go across the resistor along the direction of current, and so we get a drop in potential of ICRC, isn't it? Why the current is coming into the collector? Well, the current is coming into the collector because it is an NPN transistor, isn't it? So we get a low voltage. Why there is a low voltage? Because of good amount of IC. Why there is a good amount of IC? There is good amount of IB. And why there is a good amount of IB? Because we have sufficiently forward biased this base emitter PN junction. So because of this IC, the voltage decreases. So this is the output. So output voltage is less here in this case. For example, the RC is let's say 1 kilo ohm, which is 1000, and IC is let's say around 10 milliampere. So 10 milliampere means 10 raised to minus 3, and this VCC is 12 volt. So this becomes 12 minus 10, which is 2 volt. So if 12 volt can be considered as a high voltage, 2 volt can be considered as a low voltage. So see, this 2 volt high or low, or 12 volt high or low, it all depends on us. So before actually using the transistor as a gate, we should first make sure what are our VOH levels and VOL levels. For example, we can define our VOH as 10 volt. That means anything above the 10 volt can be considered as high, which means this 12 volt is high. Similarly, we can consider this VOL to be, let's say, around 4 volt, which means anything below 4 volt, for example in this case 2 volt. So anything below 4 volt can be considered as low voltage. So 2 volt can be low voltage. So when will this be 2 volt? When there is a current flowing. So this current flowing, because of this forward biasing, current flowing will decrease this voltage to 2 volt, and this is a low voltage as compared to 12. So this is a low output. So when we getting low output? When current is flowing. When current is flowing? When this is forward bias. When this is forward bias? When there is a positive value of input. So a positive value of input results in a very low output. So low input, high output, high input, low output. This is what is a NOT gate, that we are realizing it using a single transistor. This is a OR gate in which we are using two transistors, but actually we can do fine with the one transistor only. There is no need, but again there are two inputs, the input voltage here and input voltage here, and this is this VCC. Again we know that VCC is plus VCC, for example of 12 volts, which is supplied with the help of a battery here, isn't it? Battery between this reference level 0 and the VCC here, this point. Okay, now for this transistor to operate properly, we should first forward bias this, isn't it? So again this is an NPN transistor, so this is a NPN. Obviously you can figure it out with the help of this arrow, and this is also NPN. Now so we can have four situations here, 0 volt, 0 volt here. So let's draw the truth table for that. So this is A, B and Y. So 0 volt, 0 volt, or 0 0 1 1 0 and 1 1. See, 1 means high voltage. High voltage can be anything. High voltage can be 1 volt, high voltage can be 1.1 volt or 1.2 volt or 1.3 volt, or even 2 volt can be a high voltage. It all depends on what we choose as VI H and VIL, isn't it? And this is the output Y. Sorry. Alright, so let's start with this. So when we don't bias anything, that means we apply 0 volt here and 0 volt, that means no biasing, and then directly connecting the base and emitter with the short circuiting. Short circuiting a base emitter PN junction doesn't do anything, isn't it? So applying a 0 volt here means 0 volt here, 0 volt here means directly short circuiting the base and the emitter side. Nothing is going to happen, no current is going to flow. When no current flows, see, there is no current, and if this is no current through the emitter, isn't it, nothing happens. Transistor is in the cutoff state. So we can say that no emitter current means no emitter current means and the output is taken across this. So if no current means this is 0 volt, and no current means this is also 0 volt, because no potential difference in case of no current. Potential difference between these 2 points will come only when there is a current flow, and that potential difference will be IR. I is 0, so voltage is 0, so this output is 0, so we get what? 0. Now what we do is, if we forward bias any of this, let's say we forward bias it, let's say with 1.2 volt battery, so that is what is done here. A means high input. High input can be considered as 1.2 volt, because we consider, let's say, low input as 0 volt. So when we properly forward bias it, and we know that there is a battery also like this, isn't it, with the help of this RCC. So when this becomes a forward bias thing, PN junction, so current will flow. This is the base current which will flow because of now base emitter PN junction being forward biased. So like this, current will flow, and when the emitter current flows like this, there will be potential drop. How much potential drop? The potential drop will be IERE, and so if this is 0 volt, this will be plus IERE, and so the output will be high. So when there is a forward biasing here, the output will be high. Similarly, when we forward bias this transistor using the B positive potential at B, that means connecting the battery like this. When we put a positive potential at B, then what happens is this PN junction, the base emitter PN junction becomes forward bias, and then there is a forward emitter current which flows like this, and the collector current will go like this, the base current will go like this. Collector current and base current together make up the collector emitter current, and this emitter current will flow, and if the emitter current flows, then this will be at higher potential as compared to 0 volt, and so we get a high potential. And what if we forward bias both of them? Then even better, because now the current will be double, and the double current will create a double potential difference between these 2 points, and double potential difference means definitely this will be a high output. So high output we will get. The same thing is done here, except that this transistor, instead of drawing here, we have drawn it on this side. So this on this side means this is like flipped here. So instead of directly like this, we have to draw it like this, isn't it? And then directly like this means now this is done directly, but this like this means from VCC to the collector of this. So from VCC to the collector of this. So same thing. So if you get this kind of a circuit, you can understand that the transistor is working as a OR gate. See, in transistor as an OR gate, both of these transistors will be in parallel. That means if even one of the transistor is working, just one of the transistor working means one of the transistor base emitter PN junction is forward biased. So with the help of one only, we can drive a good amount of current through this emitter, and when we drive good amount of current through the emitter, then this will be a high volt. So what we require is any one of this to be forward biased. That means any one of this to be at high potential. Any one of this to be high potential will forward bias at least one of the transistor, and if at least one of the transistor is forward biased, that means the PN junction is forward biased. With the help of this VCC, the current is driven, the emitter current flows, this is at high potential. So that's why we are connecting both of them in parallel. Even one circuit is working, and then it's done. And then you can understand what will happen in the AND gate. We will connect instead in parallel, we will connect this time both the transistors in series with each other. So now what we require is both of them to be properly forward biased. That means this base emitter PN junction should be forward biased and this base emitter PN junction should be forward biased. Only when both of these PN junctions, base emitter PN junctions are forward biased, there is a transistor action and the emitter current flows. And only when the emitter current flows, what will happen is this, because of this emitter current, there will be a potential difference. So if this is 0 volt, then we know that the current flows from high potential to low potential. So current will go like this. So this is at high potential. How much high potential? IE RE. That is what is the output. So when do we get a output? We get a output only when emitter current flows. And when will the emitter current flows? Because both are in series, the current will flow like this, from right from this VCC here like this. See, for the current to flow, what do we require is a circuit like this, isn't it? When there is a VCC, we know that there is a battery which is applied between these 2 points, and this battery is sufficiently reverse biasing both of these PN junctions, collector base PN junctions of both of these transistors. What we require only is that just forward biasing both of them, forward biasing both of these base emitter PN junction, so that they will allow the emitter current to flow. If only one is working, another is not working, that what we will get is no current, and no emitter current means we will get a zero output. So for a non-zero output, for a non-zero output, that means one output, both of them should be properly forward biased. Both of the base emitter PN junction should be properly forward biased. If one is not working, gone. One is not working, gone. Both are not working, gone again. 0 0 0. So this is what is AND gate. Okay, the same thing which I have done here. So the output voltage is IE RE. Okay, then there can be different circuits. The thing is, in the question, you may be given a circuit and you may need to find out whether it is representing an OR gate, NOR gate, or a ZOR gate, or whatever it is. So one such circuit is given to us, and these are the two inputs, and the output is taken like this: OUT PUT, and this is a VCC given, and we have to figure out whether which kind of gate it is. So let's try to draw the truth table, taking different values of x and y and checking what is the output here. Output. Let's call it VO directly. Okay, so let's consider the case in which both are having 0 volt. So if this is 0 0, let's call it the low input voltage. So if both are 0 0, then what happens? Then the current will go like this, because this becomes a forward bias. Then the current will also go like this. No current will go like this. Why? Because this is also 0 volt, this is also 0 volt. So basically there is no potential difference applied between the base and emitter, and if no potential difference is applied, 0 0, no potential difference applied means this base emitter PN junction is not sufficiently forward biased. Not sufficiently forward biased means no collector current also, and if the collector current is 0, then if this is VCC and there is no potential drop because of no current, so no potential drop means whatever is the potential here, which is VCC, the same is the potential here, which is VCC. So we can say that the output will be high. Now what if we make X to be at high potential, which is 1, and Y to be at the low potential, which is 0. So if X is at high potential and this is at Y is at low potential, then this becomes high potential means for example, if this becomes greater than VCC or something, high voltage, then this becomes reverse bias, isn't it? Because high voltage here, low voltage here means high here, low here, so it becomes a reverse bias diode, not of much use. But this is forward bias. Why? Because this is still low, 0 low. So low voltage, now because of this low voltage, again this will, all the current will go like this, no current will go. Why? Because if this is 0 volt and this is forward bias, if this is an ideal diode forward bias with this VCC, so the current will go like this, from high potential to low potential, high potential to low potential. And because of this high potential to low potential current, this is a forward biased diode, and forward biased diode, ideal diode means no potential drop, across this forward bias. So 0 volt here means 0 volt here, 0 volt here, 0 volt here means no potential difference between the base and emitter. No potential difference between base and emitter means this is unbiased. Unbiased means no current. No current in the base, no current in the emitter means no current in the collector. No current in the collector means IC is 0, and IC is 0 means whatever is the voltage here, same is the voltage here. Again what do we get is 1. The same thing will happen when this is a high voltage, and actually what we discussed is this as yeah. So what if this is high voltage, actually that is what we discussed. This is low voltage, which is 0, and this is high voltage, which is the third case. Again at least this is a forward bias, and if this is forward biased, again there is no potential drop. So whatever it is, so all the current like this will go here, and since all the current goes here, no current goes like this, and no current goes like this means anyway this is a forward bias diode. A forward bias ideal diode means this voltage is same, this voltage is 0, this voltage is also 0. 0 voltage 0 voltage again means 0 voltage 0 voltage, no biasing, which means again 1. But what if we make both of them as high voltage, high voltage, high voltage? So for example, if we make this 12 volt, if we make this 12 volt, let's say this is for example 10 volt or something. So we know that this is these two diodes are reverse biased, because the current wants to go from this high voltage to low, which is not allowed. Again high voltage to low, which is not allowed. So no current flows like this, so nothing here whatsoever. But now you can see that there is a battery like this. So this thing is forward biasing this base, because this base is connected to the high voltage by the help of this resistor, and with respect to the emitter. So with respect to the emitter is at 0 volt, and with respect to emitter, the base is connected to a high voltage. So this becomes a forward bias PN junction. Because of this forward bias PN junction, there will be a good amount of emitter current and collector current also. When collector current flows, there is a potential drop. So when we start with high potential, we can get a drop in potential. The high potential, because of the drop in potential, will become low potential, and we will get a low output. So as you know, this is a NAND gate, NAND gate. I hope you have understood the entire working of this, and still if you have any questions, you can always ask me. And I guess this is it with respect to gate.